A warm welcome to everyone, greeting of the day, and happy learning. In this video, we are going to see about Digital Electronics Unit 5, Memory Devices and Digital Integrated Circuits. The topic we are going to cover is Basic Memory Structure and Random Access Memory. And this is Sashireka. So the course outcome of this particular subject is regarding the digital electronics, how we are going to deal with the semiconductor memories. The main objective of this video is you should define what is basic memory characteristics and explain what a RAM is and how it works. Explain the difference between static RAMs and dynamic RAMs. The main content of the video is this one, and let's start. A memory unit is a device to which binary information is transferred from storage and from which information is retrieved when needed for processing. Basically, memory is what is we are going to store something in one particular place and we are going to retrieve it whenever it is necessary. The same here also. Binary information received from an input device is stored in memory and information transferred to an output device is taken from the memory. So if we're going to see input, in the sense we are going to put something, whether since we are dealing with digital, we are putting a 0 or a 1 in one particular place. Yes, and then it is stored in the memory and the information is taken, means we are going to take it outside, that is nothing but your output, taken out from the from an output device, that is known as you're taking out, that is known as your output. So basically, memory array is nothing but a total collection of, means a large collection of cells. Each storage element in a memory can retain either a 1 or a 0, is called a cell. So it is going to store a 1 or a 0, because we are going to deal with digital. It can able to store or it can able to store a 0. Memories are made up of arrays of cells. That's what we told. A large number of cells will be there. Example, if you're going to see, this is your memory array. This is your 18 to 18. This is 16 into 4 and this is 64 into 1 array. This is a typical view of memory array. Each particular cell is known as nothing but your memory cell. So memory address, a representation of an 8 into 8 memory chip is shown. This is your 8 into 8 memory chip. The location of a unit of data in a memory array is called address. Where exactly your data is present, where exactly you want to go in a memory, that is known as your address. From where you're going to retrieve or where you're going to put your data, that is nothing but your address. Exact location you're going to specify in this total memory, that is nothing but your address. And the capacity, what is the capacity of my particular memory, is the memory address of a bit in the two-dimensional array is specified. See, this is your two-dimensional array. You're going to specify the row also, you're going to specify the column also. If you're going to see in this one, I'm specifying only the row. The address of a byte is specified only by the row here. In the blue identification, blue cells, it shows only the row representation, and here it is representing both two-dimensional, means the address column also it is specifying and the row also it is specified. And the address depends on how the memory is organized into units of data. Personal computers have random access memory organized in bytes. Most of the systems, it'll have always we deal with large number of memories. So according to that, it is organized. The smallest group of bits that can be addressed is 8. 8 means we can able to tell it deals with nibbles also if you're going to go for 4 bits. So three-dimensional array. If you're going to see, this is nothing but your array, this is your column, and this is your row. The address of blue bytes, blue is, see, this one is, you're going to specify array also, if you're going to specify row also, you're going to specify column also. The capacity of a memory is the total number of data units that can be stored. How much unit you can store in one particular memory is nothing but your capacity. Total number of memory How much unit you're going to store in that particular memory is nothing but your capacity of that particular memory. So memory bank. A bank is a section of memory within a single memory chip, memory array chip. In a single chip, if you're going to deal, that is known as a bank. A bank is a section of memory within a single memory array. Yes, you're going to deal with single memory array in a chip, that is known as bank. Rank is a group of chip that makes up a memory module that stores data in units such as words or byte. If you're going to deal with only one chip, that is known as a bank. If you're going to deal with group of chip, that is known as your rank. Right? So, what are the basic memory operations is addressing. It is a process of accessing a specific location in a memory. See, where exactly I'm going to access, which particular location I'm going to access, that is known as addressing. Where exactly my data is there, where exactly I want to put the data, that is known as my addressing. Next is your write. The write operation puts data into a specific address into the memory. Where what I'm going to do is write in the sense you're going to put something in an empty space. You are put something, going to write something. You're going to add something in a particular place. That is known as your write operation. Read is nothing but read operation copies data out of a specified address in the memory. I'm going to take a copy from that particular location. I'm going to read it by seeing it, or I'm going to tell the address to the particular memory, and then I'm going to retrieve the data. That is nothing but my read operation. So a data bus. Data units go into the memory during a write operation and comes out of memory during a read operation on a set of lines is data bus. Since we are going to deal with a lot of memories, we means a lot of lines means memory lines, a lot of address lines are used, so that is combinedly is called as bus. So we it is going to and fro, means always data lines will be in bidirectional. It is going from the input devices also, it is taken from the output devices also. So data unit go into the memory during a write operation and comes out of the memory during a read operation. So the set of lines is known as totally is known as what? Bus. So data bus. For a write or a read operation, an address is selected by placing a binary code representing the desired address on a set of lines are called as address bus. If I'm going to specify a location, in a particular memory, the binary code is placed in the address. It has to know where exactly I want to write, or from where exactly the data has to be read. That is placed in a address bus. The binary code is placed in a address bus. Set of lines. So if you're going to see, this is your single array memory. This is your address decoder. This is regarding your single array memory. This is your multi-array memory. If you're going to deal with a large number of chips, this is your multi-array memory. So a write operation. We're going to see address code 0101 is placed on the address bus and address 5 is selected. First, you are going to tell to the memory, to the chip, you are going to tell what you're going to do. So you're going to do a write operation. So you have to place a address code 101. I'm placing on the address bus. So it is taken to the address decoder and it is decoded and selected. 5 is selected, right? So then data byte is placed on the data bus. And hence, once after the decoder is decoding where exactly the data has to be written. So in this one, if you're going to see 101 and a 5 has been decoded and it is selected. So it is selected, the location is selected, then data byte is placed on the database. So whatever data I want to store in this particular location is sent there. 1000 respectively. This is stored in this particular location. Write command causes the data byte to store in address file, replacing previous data. Whatever data present in this fifth location previously, it will be replaced when you are going to give a write operation. I repeat, first you are going to give the code in the address register. Then it is taken by the address bus to the decoder. It is decoded and selected where exactly it has to be written. So if you're going to see here, it is fifth location, it is decoded and it is told that in this particular location, I want my data to be written. So this data is going to be written in this particular location, and this is nothing but your write operation, and always the data which is written previously, it is replacing, and is their read operation. Again, read operation, the address code 001 is present on the address bus and address 3 is selected. Here also, always you have to tell the address first where exactly you're going to do the operation. Whatever may be the operation, you're going to write also, you're going to read also. First, you have to tell the address. So address code 001 is placed on the address bus and address 3 is selected. So here I'm going to deal with 3. Yeah, what's that? Location 3, the address decoder is decoding and it is telling the third location. Then a read command is applied. Read command is applied. This is your second command and it is given here. The content of the address 3 is placed on the data bus and shifted into data register. The content of address 3 is not erased by the read operation. Very important. See, you're going to read it what is exactly present in that particular location. That is all. You're not going to write, erase anything. Just a copy of that one is sent to the data bus and kept there in the data register. Yeah, right. Address is sending where exactly from the data has to be read. Once the read operation is given, exactly whatever the data present in this particular location is copied, get taken a copy and it is sent to the data register, and the data is still retained there. Once you're, if suppose in the next write operation, I'm going to write a data in this particular location, then only it will get changed, or else it will not get changed. It is not erased. Understanding? So, hope you're understanding. So from this particular location, I'm going to take a data and I'm going to put in a data register. So this is nothing but my read operation, and always my data, what is present, what I have read is not erased. I repeat, first you're going to put the data in the address in the address location. It is getting into the address decoder by address bus and it is decoded. Exact location is specified. From that one, you're going to take your data to the data register. So RAMs and ROM. See, up till this we have dealing with basic